We have said this before, semiconductors are getting into almost everything around us. That, combined with the Indian government's new 76,000 crore semiconductor policy, has generated enormous excitement in the chip industry in the country. India already is very good in chip design. Many global semiconductor companies have some of the biggest R&D and engineering centers in India. Those are growing and new companies are coming in. The semiconductor policy has raised hopes that many local chip design companies will emerge, and some of them will go on to become major global companies. Today, we'll discuss this fascinating ecosystem and the opportunities it is creating for Indian talent. So welcome to this Times Techies webinar. I'm Sujit John, and I have with me my colleague Shilpa Phadnis. The two of us will moderate the discussion, which we are having in association with Micron Technology, the US-based semiconductor company. We have three seasoned professionals on the panel. We have with us Gunjan Krishna. This is the second week in succession that we have Gunjan on our platform. Gunjan is commissioner in the Karnataka government's Department of Industries and Commerce. Gunjan did economics in Lady Shri Ram College in Delhi, followed that up with a law degree from Campus Law Center in Delhi University, and joined the IAS in 2004. Among the many responsibilities she has held, she served as managing director of the Karnataka State Industrial and Infrastructure Development Corporation Limited. Gunjan has been active in the development of the semiconductor ecosystem in Karnataka and the development of other industrial clusters in the state. Welcome, Gunjan.
We have with us Chinnu Senthilkumar. Chinnu is a managing partner and CTO at Exfinity Venture Partners, an enterprise tech-focused VC fund with an emphasis on Indo-US and Indo-Singapore startups. Prior to Exfinity, Chinnu held technology executive roles in Intel, SanDisk, Texas Instruments, both in India and the US. He has 9 US patents. At SanDisk, he was the country head spearheading its India operations in the areas of R&D, operations, and IT outsourcing. Chinnu has been an innovator from a young age and received the National Technology Award from the President of India when he was 21. Welcome, Chinnu.
Thank you.
Chinnu, what was that? What was that you did when you were 21?
So I had come up with an electronic device when I was in college, which got picked up and the President of India awarded. It's to help people with speech impaired or people who are handicapped. That helps. The device helps them to communicate. Actually.
Okay.
Very nice.
And we have with us Anand Ramamoorthy. Anand is Vice President and Managing Director at Micron Technology Operations in India. He joined Micron in October 2019. Prior to that, he had a long career at Intel, where he led the South Asia sales, and later as Managing Director for South Asia at McAfee, which was then an Intel company. Anand has also served as the Managing Director for Harman India. Anand spent the first 9 years of his career in Silicon Valley as a hands-on chip designer and later moved into management and global business roles. Welcome, Anand.
Thank you, Shilpa. Thank you, Sujit.
Thank you, Anand. Those of you who are viewing this can send in questions to the Facebook comment box. Sujit and I will put them to Gunjan, Chinnu, and Anand. Anand, let me start with you first. Micron came to India late, but you already have built a substantial engineering and R&D footprint in India. Can you give us a sense of India's capabilities in semiconductors and how easy or difficult was it for you to build the R&D presence here?
Will do, Shilpa. Good evening to all of you, and very glad to be here on this forum. As you rightly said, we were a little late to the game. If I'm not mistaken, we have over 50 semiconductor players in the Indian ecosystem today across the value chain, be that be equipment makers, device makers, or service and software makers. And when you're a little late to the market, cost is not the main driver. What you come to India is because India has talent that can actually go and help you solve some of your engineering and product needs. And that was the kind of the primary motivation why the operation was started with that kind of an intent and template in mind. And also, when you are relatively late to the market, you tend to leapfrog. You tend to make sure that you have an accelerated template to go and meet some of the needs of the mother Micron that we were trying to serve. And very happy to let you know that in less than 3 years of our operations in India, this $30 billion memory storage maker company has probably witnessed what I proudly and a little immodestly called the fastest semiconductor ramp in recent history. No one has added 3,000 plus engineers in less than 3 years. And not just added engineers, what we have managed to do is have almost 30% ownership on overall programs. So net, it's a combination of strong intent, a sense of purpose and vision, which is very important when you set up an operation, and then making sure that, let's be honest here, there is talent everywhere. But what India in particular has is scalable talent. The ability to hire in large numbers, to train large amounts of people, and the kind of hunger and passion that many of our young engineers have to go and make things happen. Those are things that have served us very well in the past, and we just kind of leveraged on that to make the Micron India story what it is today.
30% ownership. What exactly do you mean?
That's a good, I should have clarified further, Sujit, and I know you would pick on that. So what I mean is, 10 years back, you had a more traditional engagement template where, I'm simplifying it for reasons of this discussion. Between US and India, which were the primary collaborators in semiconductors, you could get something going in the morning and pass it on to the India team. They would work on it, and then they'll go back and provide an update later in the day. That model is no more relevant because that is not how collaboration and innovation happens. That's a classic outpost kind of a model, and some of it is still existing. I'm not suggesting that everything has moved to an integrated model. But what we do now at Micron is, I'll pick the example of a controller. Now, though we are a memory company, if you open up any solid storage device, the controller has a very important part in playing out the algorithms that need to be used for managing the overall functioning of the solid state drive, right? And in India, for example, we own, starting from the architecture of that controller to doing the entire RTL, to making sure that it is ready for tape out. And once the silicon comes back, we have teams that start building the basic firmware and the middleware that it needs to go and become a real product. That's ownership. And it's not just a question of owning something. That makes innovation much more seamless, organic. It's also the need of the hour, because that is more efficient rather than having 3 different sites collaborate on the same program, multiple time zones, and that efficiency is completely lost. So we have such programs where of all the programs that we run for our franchisee parent company, over 30% of them are completely owned, where the contribution of the India team is material, significant. Of course, we work and collaborate other sites, but our part of the pie is significant and quite big.
So the headquarters had the confidence to give all of this to you within 3 years?
Yeah, I know. It is a little bit of a bet. That's why I said that the bet was important. And the bet is not a blind bet, because to be fair, our peer companies have also done something similar in the past. It's not like Micron was the first one to go do it. So that helps, because the peer companies have shown that with the right amount of vision, you can go and make things happen. And we have picked the programs where the natural talent pool of India is very visible. The example I gave you is because I know Chinnu will attest to it. India has a very large SoC ASIC talent pool, and that talent pool is seasoned. They've done numerous successful tape outs of silicon over and over again, and so it is a template that is very well established. We had to make sure that we put it in context for our own needs and expectations. So we cherry picked some of these programs based on the natural access to talent pool that we have in the country.
Okay. I'm sure Chinnu will also have a lot to add on this count. But before that, let me just ask Gunjan. Gunjan, give us an overall scenario in India now, that 76,000 crore policy. What kind of impact have you seen? The production linked incentives, the design linked incentives. It's the first time India has put together an absolutely comprehensive policy in semiconductors. What kind of excitement have you seen, Gunjan, both nationally and in Karnataka in particular?
Thanks, Sujit, and good evening, everyone. PLI, to my mind, have been game changers. In fact, we have 13 PLI schemes for different sectors. 3 came in 2020, and now rest 10 came in 2021. And the initial ones were related to mobile. To give an example, in India, of the total number of mobile handsets that we used to use in 2014, only 15% were manufactured within the country. And at present, 96% are manufactured thanks to the PLI schemes and the number of earlier policies that we have taken. So the idea behind the PLI scheme is essentially to increase the competitiveness of our industry, to ensure, that more export happens, to bring in efficiency, and of course, to ensure that our import bills get reduced. And we have become an integral part of the global supply chain. Our Indian companies are strengthened, and a lot of manufacturing happens here, employment generation happens here. And in that regard, we see a lot of excitement amongst the industry, because we've been talking to a number of players, be it when it comes to, like, we have Wistron. So Wistron is, in fact, Apple is adding to their capacity more and more. And government, like this year, we would be reaching a milestone. Our exports are in merchandise is actually going to reach the record level, which we will declare in March. So like March end, and when the figures come in a month's time. And now what we are seeing is in the others also. So we have these advanced cell manufacturing. So in that, again, we have, like, Excite has set it up. They didn't get in PLI, but the other two companies are located out of Karnataka, and we are talking with them. Similarly, the others, when it comes to components, when it comes to electronic goods, when it comes to LED. So we are talking to a number of companies, even for the photovoltaic cells also. So there is a tremendous response, especially in semiconductor. We know the geopolitics and the need of the hour that, we should be setting up. And we have the building blocks. We have a rich ecosystem, as Anand was mentioning, for the design. And we have 85 plus fabulous chip design company in Karnataka alone. And we have number of startups also, around 8 good Indian companies, and we have to create that ecosystem. So this will create a kind of a foundation for, future growth for the industry. And we need to learn from Israel. Like Chinnu is from the venture capital. They actually put 13% of the venture capital funding goes to the fabulous chip design companies and the other companies. So this is the first step, a very welcome step. But for semiconductor industry, we have to do more. And I can speak about, as we progress during.
Or the design linked incentive scheme, have you seen any responses on that front?
So design linked incentive scheme, definitely, but more action is right now in the fab manufacturing.
Is it?
OSAT and the OSAT and ATMP space to begin with. But for design, I think we need to do lots more. So design linked incentive is one part of it. We need to look at tax incentive. We need to look at, if there is a credit enhancement funds that, that can give them credit at all. And we need to, of course, strengthen our venture capital. We need to look at, how we can have something like centralized silicon testing and characterization, which will create a centralized, facility. And that we can give to the startup free, to the Indian companies free. And for the other companies which are coming, on the payment basis, you can really create these models. So
is that coming up? Is that coming up, Gunjan?
This is not something, but this is something that we are looking at. Government of Karnataka, we are looking at it, how we can build on these. So what I've said is that that's the first step, that's the base. And we need to, work on that foundation. And we have a very strong foundation when it comes to the design part of it. And if you see Texas Instrument, and as Anand was mentioning, silicons are in fact coming and the testing being done. So, just short of manufacturing, so many things are happening within the country. So we are focusing more on manufacturing. Of course, without IPR being with the Indian companies, also we cannot, we have to go to the next level. You have to have IPR with the Indian companies also. For that, we have to create this design ecosystem. And for all of that, these centralized silicon testing, these venture capital, these tax holidays, all of that have to be placed in the next phase that we are looking at.
Okay. Chinnu, are you there?
Yeah. Are you able to hear me?
Yeah, we can hear you. Is your screen, Shilpa, can you see?
I think my screen seems to be locked actually, but you can hear the audio, right?
Yeah.
Okay.
Okay.
So,
sure. We can go ahead actually. I think
so tell us, you are a veteran in this area. You've been with Intel, SanDisk, Texas Instruments. Now you are funding some of these cutting edge startups in semiconductors. Give us a sense of where India has reached on this front and where do you think we are heading?
Oh, thanks for inviting, Shilpa and Sujit, and good evening to all. And I heard what Anand said and what Gunjan said, and I will add to more to it. I'm very optimistic about the semiconductor ecosystem, which is evolving, because it has been evolving in the last 15, 20 years. And definitely our core strength is in the fabless design ecosystem. And when I started my work in SanDisk around 2005 timeframe, we used to do modules. But I hear from my colleagues in major companies, they are doing full chip. I think that's what Anand was talking about. So basically, whatever we have done in the last 10, 15 years gave confidence so that we can do full chip. I think where we can do even more there, like in Israel, probably we can even do the chip architecture from here itself. That will be probably icing on the cake, but I think we are not far away from that. That's where I see it actually.
So we don't do chip architecture right now, is it?
We do it, but I think in a limited manner. Anand can probably add more to it, but I think we can do more. We can come up with complex chips, completely do the architecture for the global market actually from India. And I think we have the capability. I think we need to probably have more risk-taking appetite and in a major way. I think the benchmark would be Israel actually outside of US actually. And the other thing, what I have been noticing, the IP development has been developing over the years, but still I think we can do more because we still buy quite a bit of IPs. It could be IOs or maybe different parts of IPs, which form a chunk of the chip development R&D in the beginning stages. That is coming from Taiwan or maybe South Korea. I think we can cut down that cost. I think, Gunjan was talking about localizing it actually and cutting down the import cost. This could be one area. I think we can focus on it. And in this regard, I would say the development, what is happening in IIT Madras by Professor Kamakodi is commendable. It's a good step forward, but we have to keep working. If everything goes right in that direction, what Professor Kamakodi and his
Can you explain that, the RISC-V initiative, right?
Right. So basically, what is happening is that we have been for many microcontrollers, IoT chips, relatively simple chips, we have been licensing either ARM or different kind of cores, right? And basically that RISC-V architecture, which is an open source, and what IIT Madras has taken, they are trying to productize it actually. They have started with 180 nanometer, which is pretty old node, but they have to bring it to close to like 14 nanometer or latest cutting edge technology. If the government and the IIT Madras keeps funding, potentially we can have our own cores, the CPU cores or equivalent of ARM cores in India, where we can cut down the cost actually. And this is a good development so that you don't need to buy IP or IP licensing from outside. And the third one, which is related to what I have been doing in the venture capital investment, we have invested in a company called Kinara, which used to be called Deep Vision, but they changed the name to Kinara. Kinara means edge in Hindi. So they have come up with a cutting edge AI edge processing chip. Because as you know that there is a lot of action happening in edge actually. So you need a dedicated chip. And this team, actually, the founders come from Stanford University, and they have come up with a radically new architecture. And this chip implementation completely got done in Hyderabad with about 45-member team. Not only chip, there is a software associated with it, actually. I'll talk a little bit more about the software talent we have. And this chip was taped out. In silicon parlance, they call tape out. And it was manufactured in TSMC. This was like right around the COVID onset timeframe, 2020. And they debugged in a remote way. They have brought a lot of capabilities to do remote debugging from sitting from home. And they also won the major FANG customer. I will not be able to name the customer. It's a major e-tailer. And as we speak, this chip and software, they have multi-million-dollar order, and they are doing volume sales this year, actually. This happened in Hyderabad, and Anand would know about it. They got it working in A1 stepping. That getting it working in first step is like an amazing thing. And they formed the team within 1 year, 1.5 years. They taped out the Kinara team in Hyderabad. and they got a customer, and the software also co-developed, and they have a major customer from the big five actually. So I think we have the talent, and I think what I realize is we need more capital, like venture capital or investment from big companies to recognize the talent. And I think we are definitely come, major way in the last 15 years. I think where I see opportunities going forward, I think India's core strength is also software. And if you look at the latest chips, they're all linked to software-defined memory, software-defined network. And I think, we need to bring together, and we have demonstrated in the case of Kinara, and the chip and software, they work in tandem, and that's what the end customers love it actually. I think we have a lot of potential and opportunities to work on software-defined chips actually. And I think we can really position ourselves, because here, even the established semiconductor ecosystem and Taiwan and Japan, they don't have the software capability, which we don't have it. So I think next to US, we have the combination of chip and software together. We know how to put it together and make it work and make it appealing to the end customer. And I think that's one path. I think we can really, build talent and take it further and bring a complete product from India. And in addition, I heard what Gunjan was talking about. I think this PLI scheme and the DLI scheme have been very, very encouraging. And Anand would appreciate, because I think he has been involved in the policy and other matters. And I think after a very long time, we have seen very pragmatic steps. That's what I see it actually. And like Gunjan was talking about, it's not just manufacturing. Even there is quite a bit of testing goes into it. There is a lot of business opportunity to be made in testing actually, comprehensive testing. So which we started even in SanDisk like 10, 15 years back. So there are plenty of opportunities in front of us, and the geopolitics also favors us. And the other area we can start looking at is electric vehicle and auto, because there is an increasing amount of electronics go into it actually. And there is a homegrown market in the form of EV, especially two-wheeler and three-wheeler. Many of the controllers which are designed for four-wheeler, they are not necessarily suitable for two-wheeler and three-wheeler or the battery management systems. So probably, that's an area we can look at it. So EV-focused semiconductor, especially for India market or Southeast Asia market. I think in net, if I summarize, it looks very promising, and we are on the right track. I think, from here, I do see exponential growth. I think all the building blocks have been laid out, and I think it's the opportunities in front of us. We have to just make use of it and exploit it.
Okay, a quick answer to this. Gunjan said that in the design-linked incentives part of it, there hasn't been as much excitement as the PLI's part side of it. Why do you think that is so, Chinnu?
So I'm not familiar with I know about the DLI, the design-linked initiative. Maybe it is very relatively new compared to PLI, but please remember the PLI came in different avatars earlier also. There have been a lot of tweaks. And like Gunjan was talking about, I think they have been stepping up the incentives in PLI. And there are a lot of good things also I noticed in PLI. They have expanded into auto industry, because they recognize there is a lot of electronics are going to play in auto industry. They have been expanding the scope of PLI. So I'm sure DLI also will take similar path and similar steps. It's a matter of time actually. That's what I feel actually.
And just to your question, Sujit, right, on DLI, one of the challenges that startups have historically faced this space and continue to face, right? The lead time to getting a chip, an actual silicon to production, is very long. A best case scenario could be anywhere between 18 to 24 months. And what if you're a fabless company in India or any part of the world, your leverage with a foundry like TSMC or someone else is always going to be limited, because you are a startup. You're only going to have so much in terms of market access, early market access. And unless you have someone behind you backing you, either with terms of, it could be a large multinational or a venture capital firm, which is where most people have failed. If you see exits for fabless companies, been mostly picked up by one of the large multinational companies. And the other dynamic, which is evolving, is companies, especially semiconductors, because of the nature of the business, the make versus buy dilemma is always relevant. Like, very often most companies will end up making it in-house because of the secret sauce that they often have, and they have they have the assets and mechanisms to go and do innovation, and which in turn doesn't really always blend itself into buying a lot of external IP. Right. In fact, anytime an IP becomes critical or comes in the critical path, most companies will start designing it in-house. And most of the activities generally are in the outsourced area. Hey, can you do a physical design for me? Do some black box verification. Those are not trivial. They're very meaningful, but they're not in the realm of what I call innovative design templates. Right. So that's one of the challenges which have historically been there, still there, but hopefully over time, with incentives and support, go away.
So you think with VC funding and all that, some of those could change, is it?
And VCs are not, Chinnu will agree, VCs are not in the business of charity either, right? They have to have a line of sight for ROI and how to get business out of stuff. And in fact, the opportunity actually is more in the emerging areas. If you look at the semiconductor design template, we gave the example of controller. Last year, we are probably the only company in India to have actually done a complete memory, low power DDR memory design out of India, which is huge because India is not known for memory design. That's very niche. And it came on the back of seasoned talent and high quality new college grads we hired. But the fact of the matter is, unless we are able to focus on probably the new emerging areas in semiconductors. The emerging areas is actually all the inference engines we want at the edge, right? These are not the tradition; they don't belong to the traditional semiconductor workflow, and these are converged areas. This is where I would recommend and expect a lot of startups to focus on, because don't focus on areas that a Micron or an Intel does very well, because that overlap won't help. Go and help us where we would need help between the cloud and the edge in terms of accelerating a lot of the compute functions that we keep talking about. Those areas are over and above the semiconductor part of the equation, and we need help in those areas. And every time we find, if you look at the pattern of acquisitions we've done at Micron through our Micron venture arm, they've been largely in those domains. And I know Chinnu has a few companies in that portfolio, but those are, be picky and don't go and do things that are for, it's not a question, and which the big guys are doing, and it's not a question of proving it out. It should have a business model and an outcome at the end of it, right? So
I also agree with what Anand is saying, is because the entry barrier to the technologies which are essentially you're just moving up the value chain there, the entry barrier is huge for the startups or for any company to enter. But emerging technologies and the newer technology where the entry barrier is low is where our startups should look at. And those are the companies that later get funding, and they later get even taken over by the MNCs and the other companies. So that is where we should concentrate as policymakers also.
Okay. Apart from AI inferencing, what are the other areas you think startups should get into?
No, I don't know that. I need to ask.
I think let Chinnu answer that.
So I think
would say what about array and lidar and all of these technologies? Would those be also something?
Sure.
Yeah.
So I think just to extending to what Anand said and Gunjan ji was kind of alluding to, for startups, the best areas are where there is a radical design shift happening. AI computing is one area, because if you look at this Kinara or portfolio company has come up with a new complete AI architecture, which probably was not possible in any big companies. In fact, when they got the big FANG customer, there were other established players like multi-billion-dollar established players. They could not compete in terms of architecture, actually. That's the right path to go. And AI computing, be it in cloud as well as in edge, there is a lot of opportunities for there. And also high performance computing, I would add to that, because I think the computing requirement is going to increase. So new architecture and computing requirement, that is one area I would look at it. And I think there are other interesting areas. What about the operating systems related to that? Because I think, if you look at it, the evolution of computing, the operating system and computing, they converge, then they get separated. Like, they go through the movements of like Apple and Android. So they are tightly coupled in one way of things. Then in the next wave, basically they get decoupled actually, because the software and hardware, there is a lag 5 to 7 years actually. So if you are able to spot into it, and I think you can find out good startup opportunities in that, because this has been going on from last 30 years, 30, 35 years. This will continue to do it actually. So just you have to monitor the movement of software and hardware development. There will be a catch-up game of 5 to 7 years, and you time it. Actually, there is a good opportunity for startup. In addition, actually, there is a lot of things happening around auto industry, autonomous vehicle. In fact, we have a portfolio company which is doing autonomous vehicle related startup actually. And so there is a lot of opportunity in the form of sensors and LiDAR and different kinds of computing requirements. There is a lot of overhauling happening in the auto itself. That is another area. And third, in semiconductor, power electronics, because with this electric vehicle, like I mentioned earlier, US and Europe is focused on four-wheeler. Whatever the semiconductor they come up with, it's more suited for four-wheeler, not optimized for two-wheeler, three-wheeler market in India and Asia actually. So there's a lot of battery management or power management chips actually we can work on it actually. And the other area I think is military related actually, because I think India is very keen on cutting down the import actually, and that is a perpetual evergreen business. The only thing is the funding is a little rare because the volume is pretty low. But I understand government of India has set up a fund to encourage entrepreneurs in that. And that is another area. I think there are many suitable opportunities for startup also, and also for MNCs. And just to add to what Anand was telling, that we need to be ahead in the ecosystem. I really like what ANSYS, the CAD tool company, has done. They have sponsored about 7 or 8 PhDs with fellowships in IIT Madras. I think if companies like Micron or Western Digital, if they fund several PhDs in different IITs and IISCRs, they can probably work on new memories. For example, companies like Micron, they can come up with new materials because memory is going to be shrinking and it will continue to work on the new materials. That's the name of the game in memory. So like that, major companies which have footprint in India, if they are encouraged to fund actually this PhD fellowships in our IITs, that will help us to stay, to stay ahead of the game. That's how I see from an ecosystem development.
Okay, okay, a lot of opportunities. Okay, got it. Anand, I just wanted to ask you a point that Chinnu earlier made about India being strong. Of course, we are strong on the software side, and software is also becoming a very important part of this whole chip development. So where are you focused? You have 3,000 people, you say. What kind of talent do you hire, and is software a big part of it, or is chip an equally big part of it? How's it?
Oh, true. Hey, listen, I think Chinnu stated the obvious. And software is it's abstract, but we are more in the firmware, middleware part of the equation. Equally important, because to make a silicon work, you need to have the ability to go and make those interfaces and functions work. So a big part of what we do is a lot of firmware and platform level work. At the end of the day, companies want to make sure that they are, for a memory player like Micron, our product should be able to mimic the end customer use case and workload as much as possible. And that kind of mimicking and simulation largely happens in the software domain, right? Of course, silicon has functionality, but how do you, I'll give you an example. If you're taping out a piece of silicon, we want to make sure we have a software tool for simulating the performance, what we famously call shift left, right? Much before the silicon arrives, my engineers can most likely say this is really going to work well because we have simulated a lot of it. So that's a lot of simulation software and platform work that we do in the country. And in fact, that's also an area of innovation for startups. And then post that, many of our parts will end up in a smartphone or in a PC or in a data center workload. We make sure that all of those workloads are actually being studied. In fact, we have a center of excellence in India, which actually goes and does a lot of these benchmarking. Because at the end of the day, I can talk about my innovation in memory chip. The handset maker cares about workload and use cases. For him, hey, listen, can I run a 4K video without interrupt? Can I make sure that my battery life is truly improved because you're not sucking out a lot of my power? Is your computing aligned and optimized to the overall system performance, right? These are all things that we have to keep an eye on, and that is mostly done in terms of at a system, software, platform level. So we have large chunks of those happening in the workflow, so to answer your question.
Okay. Yeah, I've been these problems that some of these electric two-wheelers have been having. I think somebody tried to go forward and it went back and all that, and easy. And they said ultimately it required some kind of a firmware update and stuff like that. So
I can promise you we were not guilty of anything of that. No, but not to make this a joke. You're right. I think because at the end of the day, it's a control mechanism, right? To think of firmware as the closest part of software to silicon, and it's important because it ensures that the algorithms and the functionality works the way it was designed to work, and it's a very key part. And Chinnu talks about software, but we found traditional software engineers, morphing into firmware and middleware engineers much better, right? It's a journey, and that's not. We had a lot of talent 10 years back, but we found that people who had that aptitude were able to retrain themselves and work in the firmware, and many of the client, in India, for example, to give you an idea, Sujit, any client, consumer, or even enterprise SSD, those drives, the ownership in India, we own the whole platform. Almost every consumer product you see in the marketplace today, you open up a crucial SSD that you sell in any of the retail stores, online or offline. Many of them are the firmware validation, the qualification, the testing. All of it happens in our labs in India, right? Okay. So yeah, it's clearly an associated field, and it plays to our strength, to be honest.
So of the 3,000 people, what proportion is software?
Hard to put a number, and I wouldn't mislead. We generally don't look at it that way because we define products in a certain corridor. The corridor could be, is it a client product, consumer product? But there is one thing is for sure: increased software, middleware, firmware content coming in. There is also a more of a generic software team that we have in the country that makes sure that it takes care of all our global tools, debuggers, you name it, right? A lot goes into making a design happen. The background software infra that you need, be that be in the CAD area or the design automation area, or in terms of driver support for many of our platforms, all of that also comes out of India. You may call it utility, but very critical to making sure a design works well.
Okay. Shilpa?
Yeah,
For
we
the
have some
sake of
Sorry.
clarity,
Go ahead, Chinnu.
when I say software, I'm actually clubbing everything, embedded software, everything together.
Sure. Yeah, agree.
Yeah. We have some audience questions coming in. This one is from Pranav Gupta. Works of fiction like Ready Player One showed a grim possibility of a metaverse-like ecosystem. How can we ensure at these foundational stages that we do not end up in such scenarios?
I'm not sure I understand the question, actually.
Yeah, if you don't mind, can you repeat the question?
Yes, this is from Pranav Gupta. Works of fiction like Ready Player One showed the grim possibilities of metaverse-like ecosystems. How can we ensure at these foundational stages that we do not end up in such scenarios?
Maybe I think you can ask him to elaborate. It's not very clear, actually.
Okay.
There's the next one.
Forget it.
It's probably a grim scenario, but we'll probably a little more commentary would help. Yeah, I agree.
Yeah, this one is from Satendra Kumar. When are we expecting a semiconductor fab in India?
I didn't expect that question at all.
Always a standard question.
Yeah, I'll take that one. I'll take that one head on, and I'm sure Gunjan would want to jump on that. I'll give just one commentary before Gunjan, and it's important. I'm sure most people on this call have this context, but just to break it down, the whole fab can be broadly broken into a front end and a back end operation, right? The front end is where you essentially work with a wafer ecosystem. That is where you have the circuitry embellished and photomasked on a die, and then these come to the back end where they get sorted, packaged, tested, and shipped to a customer or bundled with something else, right? And there is no right or wrong. The consensus emerging on the manufacturing is India is probably more aligned for a back-end manufacturing to begin with, probably because that is also a big employment generator. It doesn't have some of the strong infra and other contingencies that a front end may have to begin with. And the front end investments tend to be a little more heavier and even more super strategic compared to a back end. So not to say one is better or one is worse, you have to be practical enough to pick the one that makes most sense given where we are in a journey. And because the decisions on the front end for most large players are made at a very global level. Same is for backend, but the backend probably flows much more, safer and faster. The only other comment I want to make is even though manufacturing is not in India, just to give you an example from our Micron world, I have many of the manufacturing functions actually by proxy actually sitting in India. We have, all the, talking of software, Sujit, your earlier question and Chinnu's comment, all of the probe testing software that goes on to our testers for new memory nodes, those test solutions are run out of India. Package design, right? Designing the right packages for many of our memory and controller modules are done out of India, right? And so, that gap between manufacturing and non-manufacturing is actually diffusing, it's shrinking. You don't really have to be at a manufacturing site to drive functions like product engineering, yield enhancement. A lot of them can be done remotely. We have a beautiful concept of labs anywhere, where from my labs in Bangalore or in Hyderabad, I can actually get a peep into the manufacturing site and be able to go and either resolve an issue or collaborate actively, right? So while of course we'll keep talking about manufacturing, so a lot of the manufacturing world already exists in design centers today. Sorry, Gunjan.
Yeah, just for
Gunjan speak. Yeah.
So we are getting a lot of response and interest after the scheme was announced by the Government of India. In fact, we are talking to a number of players and many of them have been covered in the media, so we can talk about them. So Vedanta with Foxconn has already put in and they are looking at. Similarly, ISMC, which is with the venture capital, with the fund, with the private equity fund along with Tower, they are trying to work out something. IGSS is some Singapore-based company. So they are basically in the display fab and a simple, 68 and right now we are not looking at, those cutting edge fab manufacturing. But a lot of interest has come in, and I'm sure, as the scheme goes on and as we open it for the next round, more number of companies, because there are now many players are, watching how this thing will play out. And we are also having a lot of discussion with the ATMP and OSAT companies as well, because you need fab manufacturing along with the OSAT and ATMP because they come together. And then a lot of component and other manufacturing. ISA, for example, has done a study, how the gas and the, mineral industries around in India can develop. And already we found that, those who provide gas in many forms, they already exist in the country. So then we can again become an important part of that global supply chain. So lots of activity. I'm sure something will happen. Good will come out of it.
And what, Gunjan, a lot of fierce competition among states to get these projects?
Absolutely. So, of course, because it's become because it will create the whole ecosystem. And so the states are competing with each other to woo them and with the best of packages. So we also have our electronics, policy specified, a specific ESTM scheme for this. And we have gone even to the CM and, discussing. So every state is working on it. So we'll get to know who's the winner at the end of it.
Okay. So Chinnu, you wanted to add something?
Oh, I was just going to add what Anand was telling. If you look at in the last 15 years, the amount of virtual function in fab, or you can say the manufacturing ecosystem, it has come to software quite a bit. And I think it is being driven from India. It could be ERP using supply chain or all this packaging testing or quite a few virtual testing. In fact, I was mentioning about this Kinara, our portfolio. They were sitting in Hyderabad, sitting from home. They were doing testing in TSMC in Taiwan, actually. So things have come long way. Definitely, we need to have our fab for strategic reasons. I think where I like the current the approach, the pragmatic approach is instead of going and chasing a $10 billion fab or maybe $7 or $10 billion fab, which a big company like Intel can afford, and commercially it makes more sense right now. Taking an analog fab or maybe like I think I was talking about Gunjanji was talking about 70 nanometer or 68 nanometer fab, which makes sense from our learning curve point of view. Also, I see the parallel analogy in our automotive ecosystem, because if you look at it, started with spare parts, then slowly moving to engine, then the entire car being manufactured. Actually, I see a similar analogy, but only thing is we have to speed up the process.
Okay. This multiple questions coming in on the whole skilling side of it, and let me start. I mean, Gunjan can probably start off, and then others can add. There's this question from Vijaya Naidu asking any programs for starting training centers for skills required for semiconductor designs. Praveen Swami Gongde asking any initiatives to set up labs or collaboration with engineering colleges in small towns, small cities. Gunjan?
Yes. So definitely, because skill development is a very important aspect. And when we are looking at the semiconductor and the whole design industry, and then the fab manufacturing is dependent on the availability of right talent and skill set that we require. And for that, of course, you require from the PhDs to the ITIs and the polytechnics. So you have the entire range. So what we've been doing is that we have number of Center for Excellence, and we can actually ensure that, a Center for Excellence dedicated for the semiconductor manufacturing, if we are speaking about, because for design and all of that is really taken care of. And we have abundant talent pool available in the state and in India. For this, what we are looking at it is when these companies are going to come, we are looking at it that we can tie up with the universities, with the engineering colleges. We are looking at our ITI and polytechnics. We are working with number of like Tata Technologies, Siemens, and with the World Bank to upgrade our ITIs and polytechnics. Also, we are going to work closely with these companies so that they can become part of the management. And so that the skill set they require, they can design the curriculum which is suitable. And so this is how the government is looking at that, how we can ensure and work with the industry, with ISA, to create this talent pool. And for that, there has to be a multi-pronged strategy. So it would be targeting both the ends of the talent that are required. And for that, different strategies. And we are totally, comprehending the enormity of that, and we are working towards that.
Okay.
And Karnataka is very well blessed. We will be able to, do it and, scale up. As Anand was saying, that scalable talent is we will be able to provide that.
Yeah. Both on the manufacturing side as well as design, you said.
Yes.
Anand, Gunjan says design we have enough, but you said curriculum needs to change and all that in our previous discussion.
No, that's true. That's true, Sujit. Because the demand is significant, and do we have the kind of supply to ensure that these demand supply piece is in place? And what I'm finding is, I'm not complaining. Semiconductor is not necessarily a consumer facing sector, right? It is sometimes hidden behind a wonderful product or a transaction or an experience, and not having the very visible, valuable consumer connect is a hindrance. And if you're a young, very smart engineer, it is natural for you to go and explore a position. I never get tired of cracking this joke when I had this very young engineer come up and said, he was getting married. He said, and this was one of my former companies, and the joke was all about, hey, listen, my father-in-law doesn't recognize the company that I'm interviewing with. And that for me is very important because I have to feel special in his eyes. And that goes on to tell you that people have so many different reasons for picking a sector or a company or a technology they want to work on. But on a more serious note, I think curriculum hasn't changed that much. So what we have done is,
this is what VLSI curriculum, is it? This is
VLSI curriculum. And when it comes to memory, it becomes even more niche. The logic part of the curriculum is probably a little more advanced. The memory piece of it is a little less. And sometimes you can't solve a global problem. So what we are doing at Micron is making sure we have the right programs in-house when we hire a new college grad, or even a lateral hire with a slightly different talent mix, maybe a software guy, as I mentioned, trying to morph him into a more productive, efficient firmware engineer, right? So we invest in our in-house programs. Of course, we work with industry bodies and government of Karnataka, Telangana, and other governments that we work with to make sure that we are an active participant. So we do both. We kind of control our own destiny by expanding on learning and development and training programs in-house. And by now we've developed we have some good control. And then of course, curriculum needs help and not an easy fix though. That will take time in my mind.
Okay. Chinnu, do you want to add anything to that?
Yeah, I concur with Anand, and I think curriculum lacks quite a bit actually, especially in this sector. Probably they can take some practical approach. Maybe get somebody like Anand or somebody like in senior executive. Whenever Karnataka government plans for curriculum change, or maybe the AICTE, they can get industry more involved, because there has been a lot of changes in this industry, and you need to get practically experienced industry leadership to get involved. And we have sufficient leadership with enough knowledge in India, and we don't need to go even outside actually. And I think they should tap into it and utilize it better actually.
Okay. Gunjan, do you face any trouble at all in getting these educational institutions to change their curriculum?
So the curriculum is managed at the highest level as AICTE.
AICTE, okay.
That apart, but what we can do is, creating these linkages with the industry and the universities and the colleges. And within the curriculum, I think that is broadly covered. How deep you go into that is something that can be worked out. So there is nothing that for everything you need to go there.
Okay.
Some things can be worked out, and that definitely industry is only who can show us the way in this, because we need to closely work with them to get this curriculum modified. And I agree with Anand and Chinnu that we need to work more closely with them to get these necessary changes.
Okay.
And just one comment, Sujit, just building on what Gunjan just mentioned. While we can't always, change curriculum at the whim, internship proposals are a great vehicle for getting people interested in what we do. Some engineering colleges, in fact, I find more and more engineering colleges are pushing, recommending, and asking the students to go and explore different industries, and just that's our chance to go and impress them on how exciting a career can be in semiconductors, right?
How many internships do you offer in a year?
No, we do this in hundreds actually, and there's a big focus, new college hiring, and because this is where we also it's a two-way street. It's for the student or the engineering graduate to figure out what is semiconductors all about, and many of them fall in love, some have a fit issue. And for us, it's also a way of finding out, hey, is this the right kind of person that we want to hire? So it's a nice little two-way intersection. In fact, many of the interns that work at Micron end up getting full-time positions. In fact, that's our preferred way of hiring. Instead of just going to a campus and doing a draw of lots, it's much more efficient and productive if we go and get someone who's actually worked with us before, has a body of work, and we have some sense of judging his interest, our passion, their needs. So that's a big focus, by the way. That's the other way of figuring out how to get someone interested in semiconductors.
Okay. Shilpa, a lot of questions coming in, no?
Yeah, we have a lot of questions. This one is from Rajesh Kumar Gupta. Can India take advantage of the worldwide semiconductor shortfall to achieve a control in the industry as a key manufacturer? If yes, how?
Yeah, I think people in semiconductors are supply chain challenges are not new. This is a notoriously historically a volatile and cyclical industry. So and this time it has been severe for sure. And I think there are two or three key narratives emerging. One is obviously we have to be in a diversified world, be that be for talent, be that be for manufacturing. So the geopolitical mix has really shifted in the last couple of years. The recent war happening in Russia, Ukraine, I think is pushing all companies to reconsider how they are kind of hedging themselves in terms of market, sales, design, manufacturing, etc. So clearly that theme is completely well understood. And as I said, I think Chinnu mentioned this. I believe the PLI in particular is an exceptional policy statement from the government of India. And I think almost every major technology and semiconductor vendor have taken note of it. What they do with it remains to be seen. But taking note is important, because in the past they would not even take note of it, because it felt a little not tight. It did not feel like it was completely well thought of, and it did not have honestly compelling incentives. If you look at what US is doing on the CHIPS Act, semiconductor is flavor of the season, and so there's a lot of healthy competition, not between the states but also between countries. So the good part here is when there is good competition, creativity tends to take a front seat, which is what is happening. People are getting creative about how to get attention. And it's all a good thing because eventually it'll lead for large companies to take note and do something about it. So I'm optimistic because I think finally the combination of good policy, geopolitical situation, and the nature of the industry are coming together in a positive way for India.
Hey. Chinnu, you are okay.
Yeah, so I think, Anand said pretty much of it, but I think, what I see is because of COVID and, other geopolitical reasons, I think companies in Europe and US, even India, realized that they need to de-link from some of the countries like China. So this PLI scheme has been looking from that angle, actually. So I think there are a lot of incentives to localize and work out the local supply chain. And I feel, like I said in the beginning, that I'm very, very optimistic the PLI will spur the enough growth, actually. So I could say this is an inflection point. If you're looking from manufacturing, if you're looking for some kind of a growth from, not some kind of a growth, good growth from India, I think this would be a good inflection point these last 1 or 2 years, I think.
Okay. Shilpa, I think this question by Sharat Dandala is been kind of answered. He's also asking the same question about building a talent pool for fabs, which Gunjan also kind of spoke about. There's this interesting question. I'm sure, there's a lot of discussion around this now. Vimal V asking if silicon semi is to be extinct in about few years, what will be Micron's strategy for an alternative solution for silicon for its memory solution? Is there?
Yeah, so
I know things like GAN and all are coming in. The other day I was talking to Ganesh Guruswamy, a former colleague, Ganesh Guruswamy, and all. They're into GAN on GAN and stuff, gallium nitride and stuff like that.
Right. I think it's still going to be a long runway for silicon.
Silicon? Okay.
Yeah, it's a long runway, and you'll have complementary technologies always emerge, which is always good. Essentially end application based on what you're trying to optimize. But in terms of scale, because you have to understand, semiconductor is all about scale, and scale gives you the efficiencies of cost, economies of scale that you need. Because it's not about a wonderful design. I keep telling my teams too. It's about a product that can yield well. If you have a great design that cannot yield well and sell at the right price point, there's no point. Because for us, it's all about scale. So I think we have a long runway, and we've had complementary technologies for a long time, and they will continue to emerge.
Yeah, Chinnu, you finding any new things emerging?
So actually, this is not a new problem because even when I was working, I spent most of my career in memory, be it in Intel or SanDisk actually. So there is an advanced group in all these companies. They look at phase-changing memory. There are so many types of memory, polymer memory, FE-RAM. There are so many types of memory. People keep looking at it actually. But to commercially to make it viable, it takes maybe a decade or so. Just to give an example, the 3D type memory, I'm not sure Micron is using it or not, but when SanDisk started, I think it was around 2005 or 6 time frame. But I think only recent years, last few years, they made it like in mass manufacturing. So it takes several cycles and several years to get into commercially scaling technology actually. But the companies do look at it. They look at materials. They have advanced labs. They keep looking at new materials for memory, computing. Yeah, it has been going on forever actually.
Okay. Difficult to predict which one will finally become big and all that, I guess, no?
Correct.
Yeah. Okay, we are almost out of time. So final word from each of you. I think the question's also kind of done, no, Shilpa? Yeah.
Done, yeah.
So, Gunjan, final words, your advice to startups and youngsters, young engineers, what would that be?
If I have to talk to startups, so I'll say look at emerging technology, look at these cutting edge where the entry barrier is low. Look at those technology, and the design linked incentives and other incentives would be coming, and I'm sure Chinnu's venture capital fund and all of that will come together to create an IP which can reside in India, and ensure that for future we have IP set, and for future technologies we don't have to wait for so many years like the way we are creating the manufacturing here for the fab. After a long wait, that should not happen for those technology. And I feel, as rightly, there's an inflection point and we are in the right time addressing the issue of fab manufacturing. And I'm sure, this will pave way for a lot of good things to come in this.
And your advice to young engineers, what should they look for? In this industry?
Yeah, what I'll say is software is good, but hardware and looking into this, like as Anand was mentioning, is going to become cool, and they should start looking at it.
Okay. Chinnu, final words?
So it's a fascinating industry. I started as a hardware engineer. In fact, I have been always bottoms up guy. So I don't have even financial background. The financial means like financial educational background to become a VC. So I have always been in my career in Intel or SanDisk. I started like an engineer, then grew up in ranks. Same thing in the VC also. I have been engineering management, moved up in the VC career. I think semiconductor is a very fascinating industry. And the complexity which involves in the industry, if you do multiple stints, maybe 10 years, it will equip you to go in any direction you want in your life. So I think you should choose. I'm a live example for that.
Great. Anand?
No, I will end up doing a shameless plug here, Sujit, because I think memory is the heart of computing. It's at the heart of every customer experience you think of. So if you are a young engineer or a seasoned, look at memory. And if you're thinking of memory, Micron becomes a good contender. You can build a good career. I think Chinnu and I are good examples of how you can build a life and career out of it. It pays well. It's satisfying. And now with scalable operations in India, scale is important because then you're not stuck in a certain function. You can move upstream and downstream, and you can also move globally. All of us are global operations. So great opportunity to learn, apply, be a part of what we call a global transformation. So look forward to more engineers getting into this part of the world.
Great. Yeah. So absolutely. The last few months, and particularly after the semiconductor policy that the center announced, we can visibly see a big change in the entire attitude and motivations and all of that. The industry, I can see, is getting extremely excited. The global scenario is also such that India needs to really develop this sector. So in a lot of opportunities emerging. And as all of you said, for talent in this industry, if you can really understand this, the future is phenomenal. So thanks a lot to all of you, Gunjan, Chinnu, Anand. Really nice having you on this platform. Thanks again.
Likewise. Thank you for hosting us and doing this so well as you always do, Sujit and Shilpa. Thank you so much.
Thank you.
Thank you so much.
Okay.
Thank you.
Bye-bye.
Great. Bye.